Hello everyone, good evening. So here we shall solve some KCET previous year questions on the chapter Electromagnetic. So any doubts if you have in these steps, please write that in the comments section. And in any other chapter of physics, if you feel more difficulty, and also please mention the name of that chapter in the comment section. Then we should give more clarity on it and solve more questions on that chapter. And also some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So in question number 1, it is told that two similar circular coils carry equal currents in the same direction. Moving the coils further apart, the electric current will be. So two coils carry equal currents in the same direction. Moving the coils further apart, the electric current will when they are moved further apart, then what will happen? Actually, we know that parallel currents attract, and anti-parallel currents repel. So they will attract each other, but when they are kept further apart, so according to the Lenz's law, their attractive force will increase so as to compensate their increase of the separation. Since their separation will increase, they will more attract. So in order to attract more, their current in both the coils has to increase. So in both the coils, current will increase. So option C is the correct answer. In question number 2, it is told near a circular loop of conducting wire. There is a circular loop of conducting wire as shown in the figure. And electron moves along a straight line. The direction of the induced current, if any, in the loop is the direction of induced current. So an electron moves along a straight line. So here it means the magnetic field will remain constant. It will not increase or decrease with time through this loop. So since the magnetic field through the loop is constant, so the magnetic flux through that loop, that will be also constant. That means there is no induced EMF in that loop. So the direction of the induced current will be that means there is no induced current in the loop. So when the electron moves, what will happen? The magnetic field through the loop is something wrong. When the electron will move from right to left, then what will happen? The magnetic field inside this coil, that will first increase, and then when the electron will move away from this loop, then the field in the loop, that will decrease. So it means the flux, first the flux will increase and the flux then it will decrease. So it means that first the induced EMF, so it means that at first the induced current will flow anti-clockwise, then it will start to flow clockwise. So it means the direction of the induced EMF in this loop is not constant, it is a variable. So option A is the correct answer. Then in question number 3 it is 2. There is a uniform magnetic field directed perpendicular and into the plane of the paper. It's a uniform magnetic field which is directed into the plane. An irregular shaped conducting loop is slowly changing into a circular loop. So there is an irregular shaped loop, and that is slowly changing into a circular loop in the plane of the paper. Then current induced in the loop in current is induced in the loop in the anticlockwise direction. So what will so how will the current be induced in the loop? So here the AC so here in option C it is written AC induced. So here actually what is happening, the area of the loop is increasing as it changes from the irregular shape to the circular shape. The area of the loop is continuously increasing. Area of the loop is increasing as the shape changes, as the shape of the loop changes from irregular shape to the circular shape. So it means that so area of the loop is increasing, it means the magnetic flux through the loop is increasing inwards. So it means the induced current should flow in the anti-clockwise so that the magnetic field due to the induced current, that is outwards. So it means current is induced in the loop in the anti-clockwise direction. Option A is the correct answer. Then in question number 4 it is told that the energy stored in an inductor of self-inductance L carrying a current of I amperes. So the energy stored, the magnetic energy stored in the inductor, that is given as half Li square. Option B is the correct answer. Question number 5 it is told the direction of current induced in a wire moving in a magnetic field is found using the direction of current induced in a wire. The direction of current induced in a wire moving in a magnetic field is found using the Fleming's left hand rule or Fleming's right hand rule. By using Fleming's right hand rule. Since the Fleming's right hand rule is used to find the direction of the induced current in a right. So option B is the correct answer. Then in question number 6, it's told two identical circular coils A and B are kept in a horizontal tube side by side without touching each other. Two identical circular coils A and B are kept on a horizontal tube. These are kept on a horizontal tube. So this is the horizontal tube. And on this tube, two circular coils are kept A and B. They are not touching each other. If the current in the coil A increases with time, if current in the coil A, that I1, increases with time, in response the coil B, what will happen? If the current is flowing in this direction, then what will happen? Then the magnetic flux increases towards the left. Magnetic flux will increase towards the left. So it means that here the current should flow in the opposite sense. So that the magnetic field due to the induced current should be towards the right. So it means that anti-parallel currents will repel. So it means if the current in the coil A increases with time, in response the coil B is repelled. So B is repelled. So option C is the question number 7. It is to a solenoid here. Solenoid is here. It is having inductance L, which is 2 Henry. It carries a current I, which is 1 ampere. There is a current of 1 ampere. Then what is the magnetic energy stored in a solenoid? What is the magnetic energy stored in? Magnetic energy stored in the solenoid is half Li². The half into 2 into 1 joule. Option D is the correct answer. Question number 8. An aircraft there is having a wingspan of 40 meters, flies with a speed of 1080 km per hour, eastward direction. Constant altitude in the northern hemisphere, where the vertical component of the Earth's magnetic field vertical component of the Earth's magnetic field, that is B, 1.75 into 10 power minus 5 is 5. And the EMF developed between the tips of the wings. So the motional EMF, we know that motional EMF is dBm. So the magnetic field is 1.75 into 10 power minus 5. So V, that is 1080 km per hour. 1080 km per hour, which is equal to 1080 into 5 by 18 meter per second. This will be in 9 to the 18 9 to the 18 so it's 300 speed is 300 meter per second. So this will be BVL. The length, wingspan length, that is equal to 40 meter. So that will be B 300 to L. So this much volt is equal to 3 for the 1.2 into 10 power 4 into 1.75 10 power minus would be equal to 0.12 10 power 4 and become this 1 0.12 into 1.75 for the induced EMF, that is equal to the 60 90 12 90 and the 12 so the answer will be 0.21 volts. Option D is the correct answer. So here two coils are having a mutual inductance of 0.005. The current changes in the first coil according to the equation. The current in the first coil increases with I am sin omega. So it means that initially from t equal to 0 the current will increase. Here the I max, the peak current is 10 ampere and the omega, that is equal to 100 pi radian per second. Then 100 pi radian. Then the maximum value of the EMF induced in the second coil. The maximum value of the induced EMF, the EMF induced in the second coil. That will be equal to E will be equal to minus d phi b by dt, but phi is equal to mi. This will be equal to, so its maximum values are, therefore the maximum value will be this is equal to minus m into di1 minus m di by minus m into d by I, which is Im sin omega, is equal to minus m Im d by dt of sin omega t is omega cos omega. So this is the EMF. Therefore, the peak value or the maximum value of the induced EMF in the second, that is m into Im into m is equal to 0.05 into IM is 10 ampere, omega is 100 pi radian. This will be equal to, so this is 5 into 10 power minus 3 into this is 10 power 3 into 5, so this is equal to 5 pi. A is the correct. In excuse me, so here it is told long solenoid, a long solenoid there is having, so here the number of turns per unit length is 40 turns per centimeter, carries current I 1 ampere, magnetic energy stored per unit is the magnetic energy stored per unit volume. So magnetic energy is half Li square divided by volume. Volume, that is pi r square, area of cross section into the length. Now L is how to find. We know that phi b is equal to Li. Phi b is that is b, sorry, n into phi b, that is equal to Li. N is equal to n into L to phi b. Phi is equal to magnetic field into area. Magnetic field is mu naught Ni into area is pi r square. That is equal to L into I. Cancel. It is equal to mu naught n square into pi r square L. Therefore, the magnetic energy stored per unit volume of this long solenoid is equal to half L half into mu naught n square pi r square L into I square divided by pi r square into L. So pi r square will be cancelled. This is equal to half, which is mu naught by 2 n square I square. So this is the magnetic energy stored per unit volume for the. So therefore, this value we have to find. It is equal to mu naught is 4 pi into 10 power minus. So n is 40 per centimeter. So we should convert into SI unit. That is 40 per centimeter. That is equal to 40 by 1 centimeter. 1 centimeter is 10 power minus 2 meter. It is 40 into 10 power 2. So this is 40,000 meter. 40,000 per meter. 4 into 10 power 3. 10 power 4 into 10 power 3 whole power 2. I is 1 ampere. Equal to 2 4. 2 pi 10 power minus 7 into the 16 into 10 power into 32, so 32 pi into 10 power minus. So therefore the answer will be 3.2 pi. 3.2. Option A is the correct. Question number 11, it is told a wheel with 10 spokes, each of length L meter, is rotated with a uniform angular velocity omega. The wheel is there with 10 spokes, each having length L. Each having length L meters is rotated with an uniform angular velocity omega. A plane normal to the, so here suppose some uniform magnetic field acting inwards. Uniform magnetic field is acting inwards. Then the EMF induced in between the axle and the rim of the wheel, that is opposite. Therefore, here the EMF induced, suppose you have to find, then that is motion EMF, which is BVL, but at every point on the spoke, the velocity is not the same. So V is equal to therefore from the center or from the axle, suppose at a distance x we take a small element of length dx, then its velocity will be how much? It will be x into omega. Therefore the small EMF which is induced in that length at that point P x DE is equal to the small EMF that will be induced at this width, at this element equal to B BL, is B x omega into x. Therefore, the net EMF that is induced in between the axle and the ring will be equal to integral D. This will go from 0 to this will be equal to integral 0 to L d omega x dx. This will be equal to b omega integral x dx from 0 to L equal to b omega into x square by 2, that will be from 0 to L. This will be b omega L square by 2. So half omega b, this I can also write half omega b L square. Option B is the correct answer. Question number 12, it is told a bar magnet is allowed to fall vertically. Bar magnet will fall, it is allowed to fall vertically through a copper coil. through a copper coil which is placed in the horizontal plane. The magnet falls with a net acceleration. So here, when the magnet falls down, so it means that the magnetic flux increases inwards to this coil. It means that the current should flow in the anti-clockwise direction in the copper coil. So that there is the magnetic field due to the induced current should come outwards. So it means that one north pole will be induced on the upper side of this coil. The south pole will be induced on the lower side of this coil. Now north pole and north pole should repel each other. That means that this coil will also apply some repulsive force on this magnet. Therefore, the net acceleration of the magnet that will be equal to the gravitational force minus the net force means this is equal to the net force on this magnet vertically downwards. The net force on this magnet vertically downwards, that will be the gravitational force minus the force due to the repulsion. So therefore the net force is mass into acceleration, that is equal to mg this repulsive force. Now therefore A I can write G minus A by A. That means the magnet falls with a net acceleration less than G. Net acceleration of the magnet falling downwards is less than G. C is the correct. Question number 13. So, the working of magnetic braking of trains based on eddy current, alternating current, pulsating current. So, the working of magnetic braking of trains based on the eddy currents. So it means that option B is the correct answer. Then question number 14, it is told a jet plane having wingspan 20 meter. Jet plane is having wingspan 20 meters. Is traveling towards the west at a speed of 400 meters per hour. The Earth's total magnetic field is DE, that is 4.4 into 10 power minus 4 Tesla. The dip angle, the angle of dip, that is I. It is also called as the inclination. The angle of dip that is given as 30 degree. We call it as theta also. So therefore, as we know, at any point at any place on the Earth, the net magnetic field is suppose like this. Then this is the horizontal component. This is the vertical component of the Earth's field, and this angle is called as the dip angle. Each horizontal component is equal to PE plus DE, that will be equal to the means the vertical component will be equal to B is sin theta. So here we should use only the vertical component of the Earth's magnetic field. That will only produce the induced EMF across the wings of the ship. Therefore, the magnetic field here that we have to use is equal to BE, that is BE sin theta. That is equal to BE, that is 4 into 10 power minus 4 Tesla. So here the magnetic field is equal to B is sin theta, is sin 30 degree sin 30 degree. So sin 30 is half 2 into 10 power minus 4, 2 into 10 power minus 4 Tesla. For the induced EMF across the ends of the wings is equal to BVL. That the velocity of the plane is 400 meter per second. L is the wingspan, that is 20 meter. B is 2 into 10 power minus 4 into V, 400 into 10, 20. This will be equal to 8 to the 16, 16 to 10 power 3 to 10. This will be equal to 1.6 volts. So this is the voltage difference that is developed across the edge of the lens. So C is the correct answer. So hope you have understood solutions of all these 14 questions. In the next part of this chapter, we shall solve from 15 onwards. Any doubts if you have in these 14 questions, then you can write us. And so please install our Sapience application, where important previous year questions on the KCET exam will be uploaded, which shall be helpful for your. Thank you, everyone.